Hi, welcome to my channel Mathemagic with Mohsin Raza. Today I come up with this question that says that find all possible value or real values of x for which this equation satisfies, and that equation is that 2 raised to power x plus 5 raised to power x must be equals to 3 raised to power x plus 4 raised to power x. So before solving this equation, I request you, if you haven't subscribed the channel yet, so please subscribe the channel for more exciting videos. So let's solve this equation. So here the equation is 2 raised to power x plus 5 raised to power x equals to 3 raised to power x plus 4 raised to power x. So if you see, if I plug x equals to 0 in it, then what will be? Then left hand side will be 2 raised to power 0 plus 5 raised to power 0, which makes it 1 plus 1, which is equals to 2. This is the left hand side. So if we plug the x equals 0 on the right side, then we get 3 raised to power 0 plus 4 raised to power 0, which makes it again 1 plus 1, that is equals to 2, and this is right hand side. So from here you can see that left hand side is equals to right hand side. So this concludes that x equals to 0 is the one of the solution. Now if we plug x equals to 1 in it, then we get what? We get 2 raised to power 1 plus 5 raised to power 1, which makes it 7. And similarly this is equals to 3 raised to power 1 plus 4 raised to power 1. Thus x equals to 1 is also a solution for this equation. But the question is that, is there any other solution for this equation other than 0 and 1? So to show that there is no solution for such kind of equation, we use the mean value. So let's recall the mean value theorem that says that if we have a function on the closed interval a b to real number which is continuous on that closed interval and differentiable on the open interval, then there must exist some number c in the open interval such that the derivative of that point at point c will be equals to the secant line between a and b, which says that f of b minus f of a over b minus a. So what actually we were looking for, we were wanted to show that this equation has no solution other than 0 and 1. Okay, so to show that we treat x to be a constant and 2 and 5 are 3 and 4, we treat them as to be a function of some numbers, that these are the numbers. So let's say if we define a function f of t equals to t raised to power x, then this function satisfies the hypothesis of a mean value theorem on the two interval. The one interval is 2 comma 3 and the other interval is 3 4 comma 5. Okay, so this satisfies. Okay, satisfies the mean value theorem. Then if this satisfies the mean value theorem, then there exists some number. Let's say that number is t1. Then t1 in belonging to open interval 2 comma 3, on which that the function has the derivative must be equals to this quotient. So let's take it. Then this will be x raised to power x minus 1 at point t1 will be equals to f of uh, 3, which is a 3 raised to power x minus 2 raised to power x, and 3 minus 2 is 1. And similarly there exists some number, let's say that number is t2, that will belongs to 4 5, which satisfies that the derivative at t2 of this function, which is t raised to power x, but that will makes x t2 raised to power x minus 1 will be equals to what? From here, that will be equals to 5 raised to power x minus 4 raised to power x. Okay, so what we had? So we had these three equations, and from this you see that this equation says that if you take this 2 raised to power x on the other side and 4 raised to power x, so it says that 3 raised to power x minus 2 raised to power x is equals to 5 raised to power x minus 4 raised to power x. So which shows that we had x t1 x raised to power minus 1 equals to x t2 x raised t2 raised to power x minus 1. Okay, and from here we get t1 over t2 raised to power x minus 1 is equals to 1. Okay, so from here, since t1 and t2 are the distinct numbers, right? So the one thing is that x equals to 1 will satisfy this equation, but they are the distinct though. Uh, so if they will be equal, then there are two possibilities. If you see that there are two possibilities, either x minus 1 is equals to 0, which says that x equals to 1, and the other possibility for which this thing can be equals to 1 is t1 over t2 should be equals to 1, which means that t1 equals to t2, which contradicts the fact, the assumption that t1 was belonging to 2 comma 3 and t2 was belonging to 4 comma 5, right? So which means that there is no such other x that will satisfy this equation. So there is no other x other than 0 and 1 that satisfies this equation. So only solution for this equation is 0 and 1. So here we have seen the application of the mean value theorem to show that this equation has only two solutions that are very much trivial to see. They are the 0 and 1, and there is no other solution. So thank you for watching, and please subscribe the channel for more interesting and exciting videos and informative videos. Thank you so much.